Hi everyone, I hope you're okay and I hope that the videos will keep uploading are helping you out. On this video guys, I'll be tackling the second question from the Saheti school preliminary exam which was written in the year of 2023. Please do expect a total number of 11 videos since the question paper had 11 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, we are told to consider the function f of x. We are supposed to determine the limit. We are basically supposed to determine the derivative altogether, because this expression over here is just equal to the derivative of f of x by using first principle altogether. So I know that f prime of x is just equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Then all I have to do guys is to just substitute over there. For f of x plus h, this simply means that whenever I come across x on the equation of f of x, I just need to substitute x plus h. So I'll simply have negative 2a and then x plus h plus 2x plus h. Remember that guys, I'm supposed to subtract f of x. That's just negative 2ax squared plus 2x all over h. Okay, I'll end up having limit as h approaches 0. Remember that was squared over there, né? All I have to do now is to just remove these brackets. I'll end up having negative 2ax squared minus 4a xh minus 2ah squared plus 2x plus 2h as well plus 2h plus 2ax squared minus 2x all over h. And then these two will subtract one another, and these will also subtract one another, and then I'll be left with limit as h approaches 0 of negative 4ax multiplied by h minus 2ah plus, it's 2ah squared, right, plus 2h all over h. I can take out a common factor on my in my numerator. I still have limit as h approaches 0. The common factor is h. I'll be left with negative 4ax minus 2ah plus 2 all over h. I can simply cancel these two, and then I'll be left with limits as h approaches 0 of negative 4ax minus 2ah plus 2. And then now I can simply substitute h as 0. But whenever I do that, guys, I do not I no longer write limit as h approaches 0. Why? Because now I'm substituting h as 0. And then the final answer will simply be negative 4ax plus 2h. So the derivative is basically equal to this. So the limit as h approaches 0 of f of x plus h minus f of x all over h is just equal to negative 4ax plus 2. Okay, and then now I'm told that the line y is equal to x plus n is a tangent to the curve h of x at x is equal to 1. They want us to determine the values of m and n. Okay, I do have the equation of my curve. The curve is just equal to negative 2x cubed plus mx squared minus 1, right? Remember that, guys, the derivative of a curve is always equal to the gradient of a tangent at a specific point. Are you together? So if I can find the derivative over here, I'll end up having negative 6x squared plus 2m. I know that f prime of 1 is equal to 4. That means the gradient of a tangent, when x is equal to 1, the gradient will just be equal to 4. Are you together? So all I have to do now, guys, is to simply substitute. I'll have 4 on the left hand side, then I'll have negative 6 times 1 squared plus 2 mx plus 2mx, right? Okay, and then now I'll simplify this to be equal to 4 plus 6. I'll have 10 on the other side is just equal to 2m. Therefore, m is just equal to 5. Since now I know the value of m, I can therefore go and find the value of n. How so? I must first find the corresponding y value when x is equal to 1. Okay, f of x is equal to 2x cubed plus mx plus 5x minus 1. So I now want to find the value of y whenever x is equal to 1. The final answer will just be negative 3 plus 5, which is just 2. So I do know the point x is 1 and its corresponding y value is 2. I can therefore substitute the coordinates over there for me to find the value of n. Y is equal to 4x plus n. So y is 2 if and only if x is equal to 1. So therefore n is just equal to negative 2. So now I know the value of n is negative 2 and that of m is just positive 5. C has an equation of y is equal to the square root of x plus 9 all over the square root of x. I'm supposed to find the expression of the first derivative of x and the second derivative of x. Okay. Y is equal to the square root of x plus 9 times the square root of x. Now, whenever, guys, I want to find the square root, rather the derivative, the first thing that I should do is to make sure that the variable I'm supposed to derive is not under the square root and the variable I want to derive is not at the denominator. Firstly, I just need to remove the square root. Now, there's a rule that simply says the square root, the eighth root of x to the power b. This can be written as x to the power b all over a. The root of a number is always the denominator of an exponent. So this is basically x to the power 1 over 2 plus 9 over x to the power 1 over 2. Now, but I still have a variable at the denominator. If ever, guys, I want to, let's say I have c to the divided by a to the power of p. For me to make sure that this thing is removed from the denominator, I must just change the sign of the exponent. I'll still have the constant term, and then I'll have a to the power of negative p. Are you together? So over here, I'll just have x to the power half plus 9 times x to the power of negative half. So remember that this is just equal to y. Now I can find the first expression of my derivative. So therefore, let me write the derivative in black. dy over dx is basically 1 over 2x to the power of negative half minus 9 over 2 to the power of negative 3 all over 2. Remember that, guys, for a derivative, if f of x is equal to a to the power to the a times x to the power n, therefore your derivative is just n multiplied by a to the power of times x to the power of n minus 1. Just take the exponent, multiply the base by the exponent, and then subtract 1 from the exponent. So this will be our first derivative, and hence the second derivative, we are just going to derive the first derivative. Now, you'll end up having d squared. This is just negative 1 over 4x to the power of negative 3 over 2 plus 27 over 4x to the power of negative 5 over 2. This is the expression of my second derivative. That's how, guys, I was supposed to answer that question over there. Okay, and then now I'm supposed to show that the curve has a stationary value at x is equal to 9. Stationary point, guys, is also known as the turning point. Are you together? And for my turning point, I know that my derivative is supposed to be equal to 0. If my derivative is equal to 0, then I'm supposed to solve x. Now, for my stationary point, dy over dx is always equal to 0. But dy over dx is basically 1 over 2x to the power negative half minus 9 over 2x to the power negative 3 over 2. That's equal to 0. Okay, I can simply multiply each and every term by 2. I'll end up having x to the power of negative half minus 9 times x to the power of negative 3 over 2. That's equal to 0. Are you together? Okay, I can simply make this thing to have positive exponents if I want to. Is it necessary? Let's just make it. I'll have 1 all over x to the power half minus, or let's just say it's equals to 9 all over x to the power positive 3 over 2x. Né? And then I can simply multiply both sides by the LCD. This is my LCD. Né? If I can multiply both sides by x to the power 3 over 2, x to the power 3 over 2, these two will just cancel. I'll have 9 on the other side, and then on the left hand side I'll simply have x, and then I'll have 3 over 2 since they are dividing one another, right? Minus 1 over 2, that's x is equal to 9. X is equal to 9. You just have to play with the exponents over here, guys. Né? I ended up subtracting these two because I have the same bases dividing one another. Just take one base, subtract your exponents. 3 over 2 minus a half is just equal to a 1. That's why x is equal to 9. And then now they want us to find the nature of the stationary point. Okay. Nature of a stationary point, guys, they want us to find out that this x value, is it an x value at maximum or an x value at minimum? Are you together? Since we are given since they said we must find the second derivative, let us use the second derivative. There's a lot of exponents there. Okay, let's avoid using second derivative. Okay, let's use it, guys. So that you can know all the tools you can use to determine whether it's maximum or not. Né? Our second derivative is equal to that's negative 1 over 4 x to the power of negative 3 over 2 plus 27 over 4 times x to the power of negative 5 over 2. Né? Okay, if ever, guys, I substitute the value of x over here, né? If I get a positive answer, that means that x value is an x value at minimum. But if I get a negative answer, that means it's an x value at maximum. Are you together? Okay, let's just substitute over there. Excuse me. I have negative 1 over 4 multiplied by the x value is 9, the exponent is just negative 3 over 2 plus 27 over 4 multiplied by 9 to the power of negative 5 over 2. I'm finding a positive answer, guys. That means this is an x value at minimum. All right, together. The second derivative dy of 9 is just equal to 1 over 54. So since the second derivative, guys, is positive, since the second derivative is positive, therefore 9 is an x value at minimum. All right, together. Over here, the other method, guys, wouldn't work because you only have one x value. All right, together. But if you had two x values now, we're just going to substitute them on the original equation, and then if you had two x values, just substitute both of them on the original equation. The one which is smaller belongs at the minimum, and the one which is larger than the other belongs at the maximum. Right, together. But please, guys, familiarize yourself with the second derivative test. Now, if after finding the x value at turning point, use your second derivative test just to check whether it belongs at the maximum or minimum. Right, together. Whenever you substitute it, if your answer is greater than 0, it belongs at the minimum, and if the answer was negative, that means it's an x value at maximum. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos.